Do you think you need my help? Do I need to hold your hand to work out what the equation of the directrix is? Remember I said it all comes from these two equations. The first thing we do was subtract. What do you reckon we should do this time? All right, you walk me through it this time. What are we going to do? What are we going to write? What's on the left-hand side? SA1, SA2, okay. Take out the E again. A1n plus A2n. Okay. Now, which part's easier? SA1 and SA2, we were thinking about those before, okay? This time we're adding them, which makes things a little easier to visualize. There's SA1, there's SA2. You add them up, you get? You get the major axis, don't you? Okay. So that's 2A. What happens over here? A1n plus A2n. That big long distance. That's a little trickier to see. I used some time. I don't want to spoil it yet because I think we did the hard yards trying to work out what this was. I reckon you can get it. If you think you have it, call me over and I'll come and have a look. Otherwise, give you a tip. Staring at your paper with a pencil is like 10 times more effective than staring at this whiteboard without a marker. So if you can draw something on there, that's how we worked out this, remember? Yeah, give it a go. Okay, I've seen it right a few times. By the way, the key really is, because I could just give you the formula, but you can just read it from the textbook, okay? The point is, and what makes conics hard, if you're going to have any difficulty with it, is seeing where the distances are. You have to see them, okay? Not just be able to parrot out, okay? If you can parrot, then you'll be able to tell me that, what were they, 16 and 9 or something, right? You'll be able to work out what all the features are. That's fine, okay? So you can do the textbook exercise, whoopee, okay? But when you get to an actual exam question, which doesn't just, hand this to you on like a silver platter and like, whee, have a free mark, okay? When there's a challenge and it's not quite something you've seen before, this is the kind of skill you need to develop. Make sense? All right. Now, if you haven't quite got there yet, probably the easiest thing to do is to try and break these things up into components that are a little easier to work with. Okay. So, for instance, have a look at this A2n length, the long one. Okay, it's hard to work with, so let's break it up into some more manageable pieces. For instance, from O to A2, that distance there, the semi-major axis on the left-hand side. Okay, because of that symmetry, right? OA2 is equal to OA1, correct? So what I could do, just to visualize for myself, is I could take that guy and I can move him over here. That distance I just erased and this distance are the same, okay? And all I've got left on there are the lengths I was trying to add up. So I've got this component left of A2n, this part that I reflected over from the other side, and then I've got this little guy who's hanging off on the side. I've got one lot of ON and another lot of ON. Why is ON significant? Because just like before, we worked out the coordinates of the focus. This is going to give you the equation, the directrix, right? That's what ON gives you, okay? So here, what do we have? 2 times ON. That's what you should have there. Okay, but the important part is how we actually got there, right? Again, common factor of 2. What are we actually after? ON is what we want. So you divide through by E. Okay? So being that this is a distance, like it might be 5 or 12 or whatever, that distance there, the equation of this line would be x equals A on E. Okay, so this implying the directrix is, there we go. Okay. Now, how do you feel about that? Is that good? We made some decent progress? I think that's okay, that's good. We've sort of worked out where the focus is, sort of worked out where the directrix is. Now we have a problem. What's the problem? What did we set out to find again? Okay, so we were setting out to find the focus, sort of okay. The directrix, sort of okay. We know nothing about the eccentricity, okay? So there's a piece of information on here that we haven't taken into account so far. And I've sort of been alluding to it by the fact that everything I've been doing has been on this axis. What information am I missing? Yeah, I haven't encountered anything to do with the minor axis, have I? This B, this has just kind of been, well, he hasn't appeared at all because we haven't looked vertically. Okay? So what I want you to search for now, there's a lot of pieces on the board, is the semi-major axis, the semi-minor axis, and the eccentricity must be related in some way, okay? Because when you change this, you necessarily change the other two. How are you going to get a relationship between them? A relationship between them. How are you going to get it? Now, I reckon there's just enough time left today. I'm going to give you some time to give it a shot on your own. You're like, no, I hate giving things a shot on my own. Just give me an answer, okay? No, I will not give you an answer. I will eventually, but not before you've thought about it. Okay? So, there you go. There's the challenge. What's the equation that unites all of them together? Okay? Give it a shot.